Good day, I'm Dr. Roslyn Oluwaseun Ogundokun, a postdoc researcher at the Sewanee University of Technology, Victoria, and I'm here to make a presentation on the title NeuroMorphFusion, a Neuro-Inspired Hybrid Learning Framework for Interpretable Deep Laser Detection in IoT-Enabled Healthcare System. These are my presentation outlines. As a form of introduction, there is rise of Internet of Medical Things enabled real-time healthcare delivery, and the conventional CNN are computationally intensive and lack interpretability. This led to the need for lightweight, explainable, and edge deployment AI model. Problem statement. The existing models fail under low resource condition, and there is lack of transparency, undermined clinic trust, and real-time interpretable and efficient model are needed, which is proposed in this study. We propose a solution called NeuroMorphFusion, which integrates ResNet 18 with sparkling neural network and morphological attention. It is a semi-supervised reinforcement learning for sparse label, and we introduce the use of genetic algorithm for hyperparameter optimization, and a system was built with shape and grade CAM for explainability. This is the proposed model architecture. We input the CT scan dataset, which is a lung cancer dataset, and then the model was preprocessed. After preprocessing, it was splitted into 3 sets: training, validation, and test dataset. The training was 80%, the validation was 10%, and then the test dataset was also 10%, making 100 in total. And then this is the NeuroMorphFusion model with the backbone of a neuromorphical attention classifier, and then we evaluated the model with the use of confusion metrics, ROC, and grade CAM. Then the dataset that was used in this study was the lung cancer dataset CT scan, which was gotten from Kaggle repository. It was preprocessed by resizing into 224 by 224, and then we did normalization, and it was converted to TensorFlow format, because we use PyTorch for the model implementation. And then the splitting was that. Then the architecture, like I said earlier, is this, as I've shown in the diagram. And then the result, we use optimizer Adams, we use loss, cross entropy. Early stopping was introduced to prevent overfitting. EPOPs of 50%, 50 EPOPs. Learning rate was tuned with a genetic algorithm. And then these are the results that was gotten, and you can see that the proposed model, the NeuroMorphFusion, had the best training and validation accuracy. And these are confusion metrics, and in trying to compare the results of the model, we can see that NeuroMorphFusion has 0.9818, which is the highest in comparing with other baseline model. So the proposed model actually performed better in terms of accuracy. Also, in terms of time, you can see that the NeuroMorphFusion has the less time for training, which is 7.81. And then in conclusion, this is our grade CAM that was used, that was gotten from the model, and then we also compare with a state-of-the-art model, and it was seen that our model performed best. In conclusion, it's seen that we propose a lightweight model which can be used, which is efficient for edge IoT devices. Thank you, and these are my references. Thank you for listening.